Algebra 2. This is lesson 3.1, part 2. In part 1, we solved systems, which are two or more equations, by graphing. And there were three types, and you'll need to refer back to those in your notes. You can also solve systems algebraically. Under algebraically, there are two other types. They are substitution and elimination. The first part of this video is about the substitution method, and then we will look at the elimination method. If you will look at problem number 1 on the second page in your composition book, the equation is 3x plus y equals 7 and 4x plus 2y equals 16. To do substitution, the first thing you have to do is solve for a variable, and it doesn't matter which variable, but you have to solve for one of the variables, and then replace. That doesn't make much sense at this moment, but hopefully it will in just a second. If you'll notice, in this equation there is a y by itself. So we're going to solve for y so that we can do substitution. So subtract 3x from both sides, and we have y equals negative 3x plus 7. I told the 8th graders about substitution this way. This is like me calling Richard Mr. Vergara, and this y is like me calling him Richard. The y is an informal name. The equation is the formal name. Informal, y. Formal is the equation. But what this equals means is I can call this y in the second equation y, or I can call it negative 3x plus 7. So that would be 4x plus 2, but instead of y, we're going to do negative 3x plus 7 equals 16. Then you distribute 4x. 2 times negative 3 is negative 6x plus 14 equals 16. 4x minus 6x is negative 2x plus 14 equals 16. Subtract 14 from both sides, and you have negative 2x equals 2. If you divide by negative 2, then x equals negative 1. Remember, a solution is a point, so we also need the y value. We may use either of the equations that we started with to find the y value. I'm going to use the first one. So we have 3x plus y equals 7. Only we found out that x was negative 1, so 3 times negative 1 plus y equals 7. 3 times negative 1 is negative 3 plus y equals 7. Add 3 to both sides, so y equals 10. You should write your answer as an ordered pair, so this answer would be negative 1, comma, 10. With the x, then the y. You can substitute that back into both equations to verify that it is the correct answer. If you would look at number 4 now, the equations on number 4 are 2x minus y equals 7 and 6x minus 3y equals 14. Well, like we did on the previous problem, there is a y by itself. So let's solve for that y. So we need to subtract 2x from both sides. Then we have negative y equals negative 2x plus 7. Now divide by negative 1 because we want y, not negative y. So we have y equals 2x minus 7. And remember, this is Mr. Wiggins. This part is the Jacobi part. This is the informal. This is the formal. But they mean the same thing. It's like substituting a quarterback in the football game. You substitute a quarterback for a quarterback, not a fullback for the quarterback. Okay, now we're ready to substitute into the second equation. So we have 6x minus 3 times, and we're going to put the formal name, 2x minus 7 equals 14. So 6x minus 3 times 2 is minus 6x. Minus 3 times negative 7 is plus 21 equals 14. And you'll notice that 6x minus 6x cancels, so that all that's left is 21 equals 14. So you ask yourself if that is always true or never true. And the answer is 21 is never equal to 14, so this is never true. So this one is no solution. There is no value that we can put in there that will make this, that will satisfy both equations. Okay, if you will look at number 8, let's look at some of the elimination ones. 8 has 7x plus 2y equals negative 1, and 4x minus 3y equals negative 13. At this point, you need to decide which variable you would like to eliminate. It doesn't matter, we just need to make a decision. I'm going to vote that we eliminate y. Here's my reasoning. Y has a positive 2 here and a negative 3 here. In order to eliminate, because these do not have the same number with opposite sign, we have to multiply the equations. This equation on the left needs to be multiplied by the negative 3 from here. So I would have negative 3 times 7x plus 2y equals negative 1. And I would multiply the 2 times this equation. Okay, now let's distribute. Negative 3 times 7 is negative 21x. Negative 3 times 2 is negative 6y. Negative 3 times negative 1 is 3. 2 times 4x is 8x. 2 times negative 3y is negative 6y. And 2 times 13 is 26. Okay, students, I didn't look at this carefully enough, so let's look at our equation. To eliminate, we add, and we should be able to get rid of a letter. Well, we're close on this one, except they're both minuses. So I need this one to be a plus, or I need one of them to be a plus. So then let's change all the signs in that equation. When we do that, now we've got negative 29x, the y's cancel, equals negative 23. Okay, that's two examples of the substitution method. Now let's look at elimination. If you look at the word elimination, that means to get rid of. And in order to get rid of variables, you have to be able to have the same variable with the same number but opposite signs. So on number 8, you have 7x plus 2y equals negative 1. The other equation is 4x minus 3y equals negative 13. If you'll notice, the y's have a positive and a negative. So we've taken care of the opposite sign part of it. Now we need the same number. So in order to get the same number, this equation needs to be multiplied, the top equation needs to be multiplied by 3, which came from there. The bottom equation needs to be multiplied by 2 because it came from the coefficient of the y. So now let's distribute. 3 times 7 is 21x. 3 times 2 is 6y. 3 times negative 1 is negative 3. 4x times 2 is 8x. Negative 3y times 2 is negative 6y. And negative 13 times 2 is negative 26. If you look at this, the 6y and the negative 6y will cancel. So 21x plus 8x is 29x. And negative 3 minus 26 is a negative 29. Divide both sides by 29. So x equals negative 1. Now we need to find the y value. We can again substitute that into either equation, but let's just use the top one. You have 7, but instead of x, we're going to do negative 1 plus 2y equals negative 1. 7 times negative 1 is negative 7 plus 2y equals negative 1. Add 7 to both sides. So 2y equals 6. Divide by 2, and y equals 3. But again, you need to write your answer as an ordered pair, negative 1, 3. And you can check that in both equations to verify that it is correct. But to save time, I'm not going to do that on the video. Now if you'll look at number 7 in the composition book, it has 2x plus y equals 8, and 3x plus 3 halves y equals 12. Most of you do not like fractions, so there's a couple of strategies to solve this, but let's stick with the strategy that we used before. We need to pick a letter. Neither of the letters have a positive and a negative, so we're just going to have to make one negative. So if I'm going to eliminate x, just like before, this needs to be a 3, but I'm going to make him a negative 3 because one of my numbers has to be negative. Then this equation would have to be multiplied by 2 because that's the coefficient of x in the first equation. So now if you distribute, negative 3 times 2 is negative 6x. Negative 3 times y is negative 3y. And negative 3 times 8 is negative 24. Now, 2 times 3x is 6x. 2 times 3 halves y is plus 3y. And 2 times 12 is a positive 24. When you combine these, the x's indeed eliminate, go away. But so does negative 3y plus 3y. The remainder, or the answer to both of those differences, is 0. If you have negative 24 plus 24, that is also a 0. So we're back to the question of, is this always true or never true? Well, 0 is always equal to 0, so this one is always true. So the answer is infinitely many solutions.